So I'm going to make an introduction here of, let me see, let me share my desktop. So I'm going to talk about a Jupyter Notebook that we recently developed in the form of an interactive digital data report. So this is from the UC Davis centrifuge facility. We recently completed a project there. I did my PhD there and have done a number of projects there as a professor since then. And when we usually do a data report, the process is to write a static document. So this would be like a Microsoft Word document that we then convert to a PDF file, and we append plots of all of the data quantities that we measured during the experiment. And then we have this static PDF file that people can download, and they can also go and download the data and look at it if they want to. But the Jupyter Notebook provides a really nice way for us to make an interactive data report so that users can plot exactly the data that they want. And so let's see. Charlie, which of these versions should I open? Will they all work okay?
Definitely can go with this one.
This one?
Yeah.
All right. Okay, so here's our notebook data report. Let me just run everything so that you can see it. I'm sure that some of you are interested in the code, but probably the end product is better. Let me minimize that so that you guys can see it here. Okay, so this is essentially the same information that we would publish in this sort of static PDF file, but it's rendered here in an HTML format within the Jupyter Notebook. So we're mixing together here HTML and Python code to render this interactive notebook. So this particular project was a soil structure interaction project. We were analyzing culvert structures, and it's funded by Caltrans. And Caltrans was interested in understanding whether their seismic provisions for culverts are adequate. And nobody had ever really done much testing on these structures. So we configured an experiment consisting of 2 culvert structures in dense sand, dry sand. We shook the base of the model, and we were characterizing the response of the culverts. So there are a couple of reasons why I really like this, this digital data report format over the traditional static data report. In a minute, I'll have Elnaz kind of walk through this, and she can explain the different parts of it. But one of the things that I like about it is that you'll see that we're reading in data directly from a comma-separated value file. So we can set up our channel list, for example, in Excel by opening the CSV file. And then that CSV file is stored in the cloud here with the notebook. And when you open this notebook and look at it, it'll read that CSV file and render a table inside of the notebook. So you don't have to worry about having conflicting versions of the same information, right? Let's say that we realize that we reported the wrong position of a sensor. We only have one place now that we have to go to change it. And once we change it, it'll be rendered in the notebook automatically. We don't have this static document that's in disagreement with our actual data, right? So it avoids the problem of having potential conflicts. Another thing that I really like about it is that users can plot whatever data they want. So at the end of the notebook, you'll see we have a tool available where users can plot any sensor from any motion and click through it. So it saves paper. You know, before we would plot like hundreds of pages of, well, in a PDF file, hundreds of pages of sensor response plots during an earthquake. And then let's see, there was one more thing that I was going to mention, and I can't remember. Yeah, the other thing too is that we've got our drawings now are also interactive. So this is a sketch of one of our square culvert structures. Usually this would just be a static image, right, in a PDF file. But here you can zoom in and interact with it. We have this hosted on an Autodesk server. And there's an interactive feature where, let's say that we forgot to specify the thickness of the culvert, right? We actually do have it here at 0.375 inches. But you can come in here and actually make a measurement in this interactive drawing, and it'll tell you that distance is 0.375 inches. So it's hard sometimes to know exactly what information to put in a sketch that users will be interested in knowing. So by having this sort of interactive drawing available, we know for sure that users can click on whatever information they might be interested in knowing about that drawing, at least any dimension. So Elnaz, do you have it open on your computer, or do you just want to use mine?
I think that I can share my. I think that I can.
Can you share your desktop?
No, I cannot.
Here, why don't you just go through it on my computer?
Sure.
So this is Elnaz. She's the person who actually did all this work. I didn't want to take credit for it. She spent a lot of time learning how to do this.
Thank you very much, Professor, for your introduction, and hello, everyone. So I just want to show a little bit more detail about the report that we have prepared. So what we did actually, the workflow was to write the report in, let's say, LaTeX, which can be easily converted to other formats. So first of all, we wrote our report in LaTeX and then use existing commands like and converters like pandoc or HLaTeX to convert it to the HTML code. So this is kind of the preview of a code we have here. And I just want to go all the way down. So it's a long code, but when you convert it from LaTeX to the HTML, everything is available and you don't need to write everything from scratch. The only thing that we need to do is to edit it a little bit to add the features we are interested in, which was the iframes for our AutoCAD drawings and also the CSV tables that we wanted to show them as a HTML table. So then for doing that, we only added some, let's say, headers to our HTML code of the report, which is that header here, that short header for converting the CSV tables to HTML table. And also, the only changes was for adding the iframes for our AutoCAD drawing, which I'm going to show an example of that. Let me just go a little bit down. I can find it.
Maybe do a search for iframe.
Yeah, I think that maybe it should be something. Okay, here it is. So here is an example. We get that link from Autodesk. So we use the drive there, and you can get a link from that. It's like doing, like, for example, Google Drive. And then I'm just adding that link to this iframe, and when I compile it, it will appear as a frame of that figure. And at the end, the other thing that we can have is that interactive tool for viewing data. So here is what we add at the very end to, this is the one that doesn't show.
Oh.
So let me run that to see if I can get that interactive thing at the very end or no.
I think we may need to restart our server. Hey, Charlie, are you online still?
Yeah, Scott, I'm here.
We're not seeing those. We're having the same problem with the widgets not showing up. Do we need to restart the Jupyter server or something to get it to work?
Yeah, try that. Try stopping it and restarting it. I was able to get that working yesterday when I was playing with it. So
let me try another version. If it doesn't work, then we can do that.
you may also try just running that one cell and see if that brings it up.
Okay, so let me do that then.
How do we stop the kernel? Yeah, let's do that.
So let me go to the end of my code and just run the very end cell, which is that interactive thing. Okay,
there we
so
go.
here we have our interactive small tool to viewing data. So here, for example, we wrote another notebook to read the binary files that we got from the centrifuge test and converted that to ASCII files. And here is examples of the shaking events we have. So we can select the events, for example, and after doing that, we can then go through our sensors, which anyone that we would like to see, and see the results very easily next to our digital report, which I think is a nice feature to have.
Can you zoom in on that figure or anything too?
Yeah, I think, so this is the basic one, the basic figure that we are using, and we can have a zooming using the one which is provided by Matplotlib to zoom there as well to see the data. And then we can go back to the previous screen. So I think that you want to add any more detail?
Yeah, I just wanted to show the interactive table too, where
sure.
we have the CSV. We may have to rerun the whole
so
thing.
This is, no, this
Here
is
it is.
actually.
Here it is. Okay, so this table right here, this is a list of the sensors that we're using in this particular project, and this is read in from a comma-separated value. So this is not a static HTML table. It's in a little scroll window, so you see the scroll bar over here. We didn't only have like 10 sensors, right? We had a fairly,
Just
reload.
Mm-hmm.
This is the problem with live demos, right? It's always risky. Let me just run them all. Okay. All right, here we are at that table. So you can scroll down and see all of the sensors that we had in here. And again, if we have to change something, we say we recalibrate and realize one of our calibration factors was wrong, or the position of one of the sensors is wrong, or something like that. We don't need to go and remember to change it in a bunch of places, right? The Jupyter Notebook is reading it all from one source. So there's not this data version problem that might otherwise come up.